Right, morning year 8. Hello from sunny at the moment, England. And look at the rose. I grew this rose. How cool is that? It's called, I don't know, what should a rose be called? Dave. And right, so my aim here in my lovely conservatory is I've done an A3 sheet on volume, because one of your next topics is volume of prisms. And I thought, why don't I just put some key points down on this A3 sheet and then video myself going through it, and then following that load it to go for schools and make some suggestions of other videos for you to watch and a little bit of cheeky work to do as well. Right, so I'm going to go quite fast, but obviously it's a video, you can pause it. Right, volume. What is volume? Well, just think of it as a space inside something, really. The area is like the flat surface of something. Volume is space inside. Units, millimeters cubed, centimeters cubed, meters cubed. They're cubed because you're going to be multiplying 3 different lengths together, whereas area is squared because you multiply 2. Clever, huh? Uses in real life, tons. Only right, like real life stuff, there's loads. You know, volume is litres. Using that all the time, water flow, and in cooking, and there are lots of examples and I cannot think of them, but you can probably. Right, so let's do first. We've got to identify faces, edges and vertices. Pretty easy. Here's a cuboid and you just count how many actual faces, the flat faces, does it have? It has 6. How many edges? So you got 4 there, 4 here, 5, 6, 7, 8. How many lines, really? Vertices. Vertices are corners. So how many corners? There are 8. Here we have a triangular based prism. We'll go through prisms in a minute. With 5 faces. There, and then the 2 triangles. Edges, you've got all these lines. There should be 9. And vertices, 1, 2, 3, 4, 5, 6. Now there is a rule. And your first challenge is to investigate and research the rule linking faces, edges and vertices. If you can, sketch out lots of different prisms or any solids at all actually, and write down the faces, edges, vertices and see if you can find the rule linking all 3. And then you can research it, and there is a famous mathematician who developed it and found it. Okay, right, on to prisms. Prism, not prism. Sad face. Prism. Okay, now a prism, and in class I'd be really dramatic just for a change, and I would use the counting stick and imagine it as a sword, and I would chop down and go chop, 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 chop. And a prism is where you chop and you'll always see the same size face. We call that the cross-sectional area, or the area of cross-section. So if I samurai swordy chopped here, I'd see triangles. I'd see that rectangle. I would samurai swordy chop here and I would see circle. These are not prisms, because no matter what angle you chop at, yes, you would always see a circle. Circles would be different sizes. Circles, different sizes. Okay, so not prisms. Prisms. Right, imagine it as a loaf of bread. There's that bread advert, isn't there, with like the front bit of bread has a face on it and then it falls over and the other one laughs. Anyway, too much TV. Right, so that's a prism. Now, to find the volume of prism is really easy. No matter what the prism is, as long as when you cut it you'll see the same front area, you get the area of cross-section and times it by the length. So that area of cross-section times by the length. That's how you work out the volume. What's this? Oh, tracks. Let's follow them. Aha! They lead to some examples. Oh, I'm going to knock over the music stand I'm doing this on. Right, so volume. Volume of that puppy. I don't want you anymore for the rest of your life to think of volume as a cuboid or just multiply them. What you're really doing is you're finding the area of cross-section by multiplying 2, then you're multiplying by the length back. Yes, you could be Mr. Picky and say, well, you're just multiplying all 3, but if you always think of it as area of cross-section, it will help you in your exams. because they'll ask you backwards questions and stuff. So cross section is 20, length back is 2, 20 times 2 is 40, put the correct units, meters cubed. Area cross section, how many people will get that triangle wrong? 4 times 5 divided by 2, because it's a triangle, then times 2 back is 20. Cylinder, again a prism, you'd chop this way and always see the same circle. Remember the circle song? I miss the circle song. Pi r squared sounds like area to me. Pi times radius squared, that's a diameter of 4, half it to get the radius. Pi r squared times the length, that gives you the volume. Pi is 3.14, radius is 2 squared is 4. That times that gives us 125.6 meters cubed. So we can work out the volume of any classic prism. We can also do other ones where they don't shade it in for us, so here we've got a triangle, height is 5, perpendicular height is 5, base is 4, 5 fours are 20 divided by 2 is 10, multiply by length back is 6, you get 60. This is a compound prism, so what I would do to calculate the front area, split it into A and B. So then area A is 7 times 2, which is 14. There we go. And area B, if this whole thing is 8 and that's 2, that must be 6. And that's 2. 6 times 2 is 12. 14 plus 12 is 26. Times the length back of 3 gives me 78 meters cubed. Okay, so that's how to find the volume of a prism. You essentially find the cross-sectional area, multiply it by the length back. Now they're not going to do that in an exam most of the time. They're going to put it in context, but that's all good. We'll be fine with that. So in context, how many litres would a swimming pool, dimensions 12 metre length, 3 metres depth, 4 metres width hold? Quick sketch to get my head around it. So volume is cross-sectional area, which is 3 times 4, which is 12. Multiplied by the length back of 12 gives me 144. That's 144 metres cubed. And it said how many litres I need to convert. Now, we need to know the conversion that 1 metre cubed is 1,000 litres. Okay? There are two conversions. One is that 1 litre is 1,000 centimetres cubed, and the other one is that 1,000 litres is 1 metre cubed. So a block that's a metre by a metre by a metre would hold 1,000 litres, which is a lot of water. So we've got 144 metres cubed, so we're going to have 144 times 1,000, 144,000 litres. So a lot of water in that swimming pool. Now, a super extension for if you wish to push it and look at combining with density, because they do this quite a lot. Now, we haven't covered density, but it's fairly simple. Density is mass divided by volume. Okay? What I do is same triangle. Remember speed, distance and time. Speed, distance, time. So if you do this, density is mass divided by volume. If you want density, you do mass divided by volume. If you want mass, you do density times volume. And if you want volume, you do mass divided by density. Now, imagine one of those blocks of gold that you see like in the crime films, and they've got those big bars of gold. How much do they actually weigh? Well, the actual real-life density of gold is 19.3 grams per centimetre cubed. So if I had 1 little centimetre cube of gold, it would weigh 19.3 grams. Doesn't sound much, but you just wait. The block is about 8 centimetres high, 10 centimetres long and 30 centimetres in length, I reckon. If we calculate the volume of that, and we want to work out how heavy that block is, right? So we know its dimensions, we know its density, calculate the volume. Front area is 8 times 10, multiplied by 30 gives us 2,400 centimetres cubed. That's its volume. We know its density. So to get its mass, we multiply density by volume, which gives us 46,320 grams, which is 46.32 kilograms. So that one block that you see him on the films throwing around from a cart into a van or something weighs nearly 50 kilograms. Not sure the films are right. Anyway, that's it. I'm going to set you some work and some extra videos if what I've said is a little bit not clear. And email me for any problems. Goodbye from me and goodbye from Mr. Rose.